So today I'm going to continue to discuss logarithmic and exponential functions. I want to just look at each of them and tell you one more requirement. If I have my function equal a to the x, that's my exponential function. F of x equals log base a of x, that's my logarithmic function. A has to be a real number, a has to be greater than 0, and it cannot be 1. First thing I'd like you to do is evaluate each of these logs, and I'd like you to try and generalize a property for each of them. Press pause, and when you're ready for the answer, press play again. So log base 3 of 1 is 0 because 3 to the 0 power is 1. That generalizes to any base. Log base a of 1 is 0 because a to the 0 is 1. Any positive real number raised to the 0 power is going to be 1. The second example says log base 6 of 6 is 1. That's because 6 to the first power is 6. That will generalize to any base. Log base a of a is 1. That's because a to the first power is a. I'd like you to make a place in your notes for properties and start listing them. These are the first two you should list. Press pause on the video, and when you're ready again, press play. The next thing that I'd like you to do is evaluate each of these logs and try and generalize one property. When you're ready for the answer, press play again. So you'll notice the first problem, 3 to the log base 3 of 81 is 81. 10 to the log base 10 of 100 is 100. 2 to the log base 2 of 8 is 8. That generalizes to a to the log base a of x is x. Now let's think about why this happens a minute. So this here says, this problem says 3 to the log base 3 of 81. Well, log base 3 of 81 says 3 to what power is equal to 81. Whatever that exponent is here that we get, put that on the 3. So what we're going to get out is just 81 because it's saying put whatever exponent on this 3 that will give me 81. Therefore, the answer is 81. So again, a to the log base a of x is x. Add that to your property list. Next, I'd like you to evaluate each of these and try and generalize another property. Press pause, and when you're ready for the answer, press play again. So log base 2 of 2 to the third is 3. Log base 4 of 4 to the fifth is 5. Log base 5 of 5 squared is 2. That generalizes to base a. Log base a of a to the x is x. That's because if you look at this, log base a of a to the x says what exponent do I have to put on my base here in order to get a to the x? Well, of course, that's x. That's why that works. Add that to your property list. Now, I hope that you noticed that logarithmic functions and exponential functions undo each other. If I take log base a of both sides here, I get out x. Log base a of a to the x, they undo each other. I get out x. A to the log base a of x, I get out x. They undo each other. They are inverse functions. Another property that I'd like you to add to your list is this. Log base a of x, if I have that equal to another log base a with a different argument, then the arguments must be equal. Now, one more notation kind of piece that I want to mention is that log base 10 of x is just equal to log of 10. So in other words, I don't have to put my base 10 in. That's because it's a really, really common base. So instead of listing the base over and over and over again, we just simply omit it, and that means log base 10. The other one is log base e of x. We write that as ln of x. And again, my base here is e. That's because e, remember, e is your irrational number. And I told you that's the natural base, which I will explain on another day. But the notation for this is ln of x, the natural log of x, log base e. So we're not writing the base over and over and over again. Now, here is a summary of all the properties that we've discussed. Make sure that you have them listed in your notes. We can evaluate logs in a calculator. You'll notice on the main screen here, I have log, just L-O-G, and ln. So log is base 10, ln is base e. So we'd like to be able to evaluate logs with different bases in our calculator, and for this we use change of base formula. Log base a of x is equal to log base b of x over log base b of a. I can change my base from a to b, and here's a couple examples. So if I wanted to evaluate log base 6 of 20 in my calculator, I could do log of 20 over log of 6. That's log base 10 of 20 over log base 10 of 6. Same idea here. Log base 2 of 35 is log of 35 over log of 2. And that will get me a nice decimal approximation. There is another function in our calculator where we can actually enter the base, but I do want you to know the change of base formula because most of the time if you're dealing with a scientific calculator, you are dealing with just log base 10 and log base e. Now, a few more properties that I'm going to want you to add to your notes in your list are these. I am putting this link to a Khan Academy site that explains why each of these properties work in detail. They give proofs. If you're interested, you can check that out. But I'm going to just explain in general why they work. So if you look at the first property, it says log of a product is equal to the sum of the logs. Now remember, logs are exponents. So when you are multiplying two bases together with exponents, what do you do to the exponents? Well, you add them. So log of a product is equal to the sum of the logs. Oops. The next property is log base a of a quotient. The log of a quotient is equal to the difference of the logs. If you think about exponents, when you are dividing, the rule for the exponents is that you subtract. Same kind of idea here, and again, if you want proof of this property, it's going to be in the link that I will post online. Here's another one. Log of u to the n. That means I can take this exponent and move it out in front of my log. Now think about this. If I have a base raised to a power and then raised to a power after that, you multiply exponents. So here's an exponent. My log is an exponent. I multiply my exponent by my log. And again, proof of this is out online. Now we're going to use these properties to expand and condense logarithmic expressions. So here is my first example for expanding a log. So I have log base 4 of 2 times x to the third times y squared. So remember, log of a product is the sum of the logs. That's log base 4 of 2 plus log base 4 of x to the third plus log base 4 of y squared. Log base 4 of 2 is a half, and then I can move these exponents to the front. So it's a half plus 3 log base 4 of x plus 2 log base 4 of y. The next thing that I'd like you to do is try this problem. When you're ready for the answer, press play. Okay, here's my answer. It's log of a quotient, so it's the difference of my logs. So it's ln of 2x plus 1 to the third minus ln of y. The exponent moves to the front. In this example, we're going to condense. So I have the difference of logs, except I have this coefficient out in front. So I have to move that to my exponent. So that's log base 2 of x minus log base 2 of x plus 1 squared. And the difference of my logs is the log of the quotient. So that's log base 2 of x over x plus 1. The next thing I want you to do is try this problem. When you're ready to see the answer, press play. So again, I have to take my coefficient and move it to my exponent out here. And then the sum of the logs is the log of the product. So this should be your answer. The next thing I want you to do is the assignment that I've posted for you online. Have a great weekend.